Hi everybody, this video about vibration screens. My name is Yuri Avalar, I'm from Ukraine. The first indications of use of screenings technology are found in Egyptian ruins dating back in 1500 before Christ. With the advent of the Bronze Age, pigment, salt, metal ores and coal begin to be screened after a certain period of time. Non-metallic ores and various chemical components fall under the certain. During the European scientific and technological revolution at the end of 17th century, the popularity of screens for dry separation increased. And from the end of 19th century, preference for screening material is given to sieve metals. Screener, one or more vibration sieves for separation bulk materials according to the size of lumps or fractions. Screening is used for solid minerals, construction materials, abrasive materials, solid secondary raw materials and some typical of organic materials. Among all types of materials there are screened ferrous or non-ferrous metals, ores and non-metallic materials. Coal, granite, limestone dominate. According to a rough estimate, about 2 billion tons of solid raw materials are screened annually in the world. It's necessary to separate bulk material by size, which are represented by partials of different sizes for technical purposes. When it's required to obtain raw material of a certain size, range options from and to, no larger than, no finer than. In the simplest version, as a result of screening on one sieve, two products are obtained: large oversized top and small undersized bottom. Screening operations are usually used in conjunction with crushing, disintegration processes. Screening operations, like other sizing methods, are mainly used to solve the following problems: to separate a fraction of raw material of a certain size from one stream of crushed, disintegrated rock masses, which is required for subsequent technological operations, or to return a coarse fraction for additional crushing, the so-called closed crushing cycle. To highlight marketable products of specified size classes, for example, to obtain narrow fractions of the size of construction crushed stone of abrasive materials. For separation raw materials into parallel streams and subsequent processing of materials of various size using different technologies. It's practiced, for example, in enrichment of rare metals ores, diamond ores, in the deep processing of solid industrial and domestic waste. The principle of operation of screens is the next. In the mining industry, most common screens for the classification of dry materials are spring-supported vibration machines with one or more rectangular screening surfaces, sieves, installed in the open box on the discharged side. There are several sieves. That's a multi-sieve screen. The sieves are located one under the one from large to small. The vibrations of the box is provided by unbalanced vibration exciters, which are mounted on the screen box and are driven by asynchronic electric motor. At present, the most common design of vibration drives, vibration blocks of screens, is a motor landing on the same shaft with an imbalance. The usual speed of rotation of the motor of the vibration drive is 1000 revolutions per minute, less often 1500 revolutions per minute. Despite the fact there are many known designs of vibration screens in the modern practice of the mining industry, two main types of vibration screens are massively used, differing in the type of vibration. Type of screens. Inertial screens. The first so-called inertial type of screens is equipped with one vibration drive that imparts orbital vibration to the screen in a vertical plane. To transport material over the sieve, the box of the inertial screens is set at the angle of 7 to 17 degrees to the horizon. Self-balancing screens. The second type of screens, the so-called self-balanced or self-synchronous sizes, is equipped with two vibration drives operating in antiphase and creating rectangular vibrations of the box. This type of screens allows for the classifications and simultaneous transport of material over the sleeve, and therefore can be installed either horizontally or with a slight angle to the horizontal. Self-balancing screens provide a slightly higher accuracy efficiency of separation by size and require a lower construction height for installation than inertial screens. However, they consume 10 or 20 more electricity. Self-balancing screens. To increase the efficiency of screening ores containing clay and fine-grained partials, sometimes wet screening is used, using a large amount of water supplied to the sieve. At the same time, it's necessary to solve the problems of subsequent dehydration of screening products and reuse of water. There are many types of screening surfaces of vibration screens. The most common are sieves with square or rectangular openings, meshes. The sieves are quickly worn out elements of the structure of the screen. Therefore, they are made from wear-resistant material, such as steel with rubber lined, from special grades of polyurethane or special rubber. The wear resistance of sieves increases in the reduced range from steel to polyurethane, and the cost of sieves also increased in this range. And in Ukraine, it's able to produce the most cheapest in the world rubber sieves. Modern vibration screens are capable of processing raw material with a particle size of from 300 to 0.3 millimeters. We offer screens of various designs, productivity and screening surface area. The use of extensive experience in the production of screening units allow us to create machines that differ from analogs on the market in higher efficiency and along our whole period. Many of our vibration screens are one-of-a-kind solutions for challenging tasks.